Good afternoon, everyone. Welcome to this webinar. This is one of the Secrets from the Support Vaults webinars. I don't know which number it is for this year, but we've done quite a few. We are going to talk about one subject today, and that subject is Sifter. In case you don't know what Sifter is, that's fine. I will explain that as we go along. The goal here is to keep this webinar to, I think, between half an hour and 45 minutes. If you have any questions, look at the GoToWebinar control panel. Normally that should be on the right-hand side of your screen. In there is a section where you can type questions. This is a webinar, so you cannot speak up. There are too many of you out there, but you can type questions in that GoToWebinar control panel, and I will look at all questions either during the webinar or at the end. And we'll make sure that they get answered, of course. This webinar is about Sifter. Let me give you a little bit of an introduction to this. Sifter is, well, it's something that refers to using a sieve of or filtering objects, and the long name of this is ContextAware object detection. And if you look in pdfToolbox, you will find both the name Sifter and ContextAware object detection used in different parts of the application. And I will point that out as we go along, of course. Now, Sifter refers to an advancement to preflight technology. And you can wonder whether preflights still needed to be advanced, because many people say that preflight is a commodity technology these days. So why would you introduce new complications in preflight? And the answer to that is actually quite simple. It's because you need it. And that might not be immediately apparent, but I can explain quite easily. So if I can get my mouse to cooperate with me a little bit here, that would actually be quite nice. No. So why would you need Sifter? And let me see if I find another way of doing this. Oh, this is really cool. Sorry about this. So much for using Microsoft technology, I guess. There we go. Let me try that again. Yes, very good. There's what I wanted to show. Okay, so why do you need Sifter? Well, because preflight, as it is typically used, historically used, has a problem. And I can illustrate this with a very simple example. And it's not even a document, it's simply two objects. I have a blue rectangle here and a red circle. Now, if I use traditional preflight software, it can answer questions for me. And some of the questions that it can answer are there any blue objects? And I could conceivably even write a preflight check that tells me how many blue objects there are. Are there any red circles? You can tell whether objects are of a particular type, or whether their colors are correct, whether they have certain attributes. But all normal preflight does is it looks at each object on a page individually. So typically these preflight checks look at individual objects and their parameters, and then tells us whether something is good or not good. And this technique can detect a lot of problems in PDF documents, but unfortunately there is a whole range of questions that cannot be answered with that traditional preflight technology. For example, are there any red circles on top of a blue object? normal preflight simply cannot answer that because it will look at the red circles on the page individually. It will look at blue objects individually, but it cannot make a relationship between the two or test a relationship between the two. So you also can't say whether any objects are being hidden by a blue object. You can't say whether an object is being clipped away, because that would be relationship between an object and a clipping path on the page. And this is exactly why Sifter, or this context-aware technology, was invented. Sifter looks at relationships between objects. Now, that sounds really clever, but you could conceivably think that that's simply a complication, a theoretical concept, and that it has no real effect in real life. But it's actually quite simple to give you examples of where in real life Sifter will let you answer questions. And I have two documents here, and this is the last slide that I have here because I want to show you this in pdfToolbox. But I have two objects or two pages on here on this slide. On the left-hand side, I have a page that has some small black text at the bottom there. It's hard to see because it's black on blue, but it has some small black text. On the right-hand side, I have the same page. The layout is exactly the same. The only thing that is different is that the black text at the bottom is on the paper itself. There is no blue object there. Now, if that black text is set to knockout, which, well, traditional preflight software will detect, because black text on knockout can cause registration problems, and typically you want to detect that in a preflight run. If that black text is set on knockout, there is a big difference between these two documents. The document on the left is actually a problem document that needs to be looked at. The document on the right will go through production just fine. Why? Because the black text is not set on top of anything else. Now, let's look in pdfToolbox what that means. So I have the same document open in pdfToolbox. This is the one that has the blue background object. And then I have the same document open in pdfToolbox, but this time without that blue background object. Now, what happens if we preflight this with traditional preflight technology? And I have a check here, and if I open that check, you can see that it tests a number of parameters of the objects in the file. So it looks whether overprint is enabled, and it makes sure that it is not. So this condition basically says, is this object set to knockout? Then it looks at text size, and for objects or text elements that are smaller than 12 point, and then it looks at whether an object is 100% black. And if we run this on our document, then it gives me, you can see that here, it gives me 3 matches. Yes? This is a little bit surprising. So let's double click on the first match there. And what you can see is that apparently there is some text line here that is completely hidden. The technical term that pdfToolbox uses is obliterated, completely hidden by this nice penguin. And if I do show in Snap, which shows me the object that causes a particular problem, then you can see that there is in fact a line of text behind that image. So that's the first one that pdfToolbox finds. Now, of course, this line of text is never going to cause a problem afterwards, because that line of text is completely behind this image. It's an opaque image, so that line will never be visible, but it's still detected by our preflight run. And then secondly, I have these 2 lines at the bottom. And of course, in this case, the traditional preflight technology is correct. These 2 lines you should know about and probably need to be set to overprint if you want to get the correct result. So 3 hits in this document. And now go to the second document, and we're going to run the same preflight check on there. And when I run that, I again have 3 matches. Well, the same ones as before. And this is what we expected, to be honest, because the only thing this preflight check does is it looks at all text elements and tests these parameters of those text elements. So whether they are behind an object, whether there is something else that they are printed on top of or not, all of that is irrelevant for this check that we have. So we get the exact same results. So what will happen in an automated workflow? Well, in an automated workflow, this document will be stopped because it has errors, and correctly so. The operator looking at the documents might be slightly surprised because there are 3 matches here and there are only 2 apparent problems, but that's not too bad. This is a problem document and it should be stopped. The problem in an automated workflow is that this document is also going to be stopped, while there is no reason to stop it at all. This document will be printed completely without any kind of problem. And whether this black is on overprint or knockout makes no difference whatsoever. So this is a classic case of what we call a false positive. We do a check to detect production problems, but in the end, we end up stopping a document that really isn't a production problem, but an operator will still need to spend time on figuring out what is wrong with this document. And after being surprised a little bit, he's probably just going to release it and print it without any further problem. If we do the same thing here, so let me go back to my first document and we do the same thing, but now we take a check that is using the Sifter technology, and I'll show you how that looks in a second. If I run this on this document, then I get errors, but I only get 2 errors. Why? Well, because the Sifter check that I use has discarded or ignored any object that is obliterated or hidden. And secondly, well, it still detects the 2 text lines that actually are a real problem. So in this case, I get a completely accurate answer on whether this is a good document or not. It is not, and there are 2 text lines that cause that. If I go to my second document and I use the Sifter check, then pdfToolbox tells me no problems found. And this, again, is the correct answer that you would expect in an automated workflow. There are no problems here because one of these text lines is obliterated or hidden, and thus it is not counted. And these 2 text lines, well, they are set to knockout, but because they are not overlapping other objects, there can never be a registration problem. So I don't want to spend time on them. So where the classic technology will give me a hit on both documents, the Sifter technology in this particular case gives me a hit on only the document where I actually want to get a hit. There is no false positives. And this is the main advantage perhaps of Sifter. There are actually 2 big advantages, but the main advantage perhaps is that, especially in these automated workflows, by using Sifter in a clever way, you can avoid a lot of the false positives that you would typically get. And by doing so, the number of documents that can simply flow through completely automatically from being received to being printed becomes much higher. The percentage of documents that will be stopped will be lower, and the percentage of documents that are stopped correctly will be much higher. In other words, those documents stopped by your workflow will now really be documents that have a problem and that someone needs to look at. By the way, this is only the first advantage of Sifter. I will also show you something afterwards that is simply not possible using classic preflight technology. So Sifter also enables you to implement preflight checks that with classic technology simply could not be done. I hope that is clear, and let me go into this check for a second. And I saw a question come in about performance. It's a very good question, and I will talk about it at a little bit later in this presentation. But first of all, let me dive into this check a little bit. And Well, we looked at this classic preflight check, and there we saw that we were only checking attributes of one particular object. And actually that classic check is used inside of that Sifter check. What you see here is a condition that comes out of a group called ContextAware object detection. And that is a new group in pdfToolbox 10 in this list of condition groups, ContextAware object detection. And if you select it, you will see a whole list of possible conditions that you can use. And the first one is the generic one that is also marked with the word Sifter itself. What we're using here is a simple condition derived from the more generic one. Which condition? Well, the condition itself is called object on top of other objects. So basically, this condition is only going to give us a hit, a pre-flight hit, if it detects one object that is on top of another object. And using these two pull-down menus, and these two show me the complete list of pre-flight checks I have in my library, using these two pull-down menus, I will now define which object on top of what other object I am interested in. And you can do all kinds of combinations here. What I'm using in this particular case is I'm using this classic pre-flight check for black text knocks out and is smaller than 12 point. That's the one we tested first. And as a second one, I'm using any page object. So what I'm saying here is that Sifter needs to give me a pre-flight error if it finds any black text element that knocks out and is smaller than 12 point that is on top of any other page object. Yeah? And that's why I said that Sifter tests relationships. You define what category of objects you are interested in, and in many of these Sifter conditions, you will have to define two collections. You define what type of objects you're interested in, and then you test a relationship between those objects. And the relationship that we have here is on top, but you can see in the list that there is a long list of relationships that you can check. I could also check whether something is below another object, whether it is completely covered, whether it covers another object completely, whether it crosses through the edge of an object, whether it's inside or outside, whether it is partially or completely clipped by another object, whether it's partially or completely obliterated. Remember that obliterated means that there is another object on top that hides that object in the back completely. So all of these conditions internally use the Sifter technology to do their work, and usually that involves testing relationships between one object and another object, or one object and a collection of other objects. Yeah? And the result is that you do something that is much better than what you could do with classic pre-flight technology, and you avoid a lot of false positives. Now, let me take, before I talk about this performance, let me make things a little bit more challenging, shall we say, because this is still a relatively easy application of Sifter. And I have another document here that is also very interesting when we start looking at Sifter. This is a label. It's a label for something that I would never eat, pumpkin yogurt. I have no idea how that will taste, and I hope I never do. But it's a label that has a cut line, and I can show you how the cut line is defined if we look at the individual separations for this document. And then you will see that there is one separation called cut line, and that separation has a vector object that defines where this label is going to be cut out. Now, using this, I can do all kinds of interesting things with Sifter. And the first thing that I want to show you is that And this is something that is impossible with the classic technology that you had in pdfToolbox 9. We can check now whether there are any objects, and typically what you would be interested in are text objects, whether there are any objects that are too close to this cut line. Because what you want to avoid is that text comes so close to the cut line that a little bit of a misregistration using cutting or even applying the label to the final container would cause text or characters to disappear. So you don't want text to be too close to this cut line. And there is a Sifter check here. I'm going to run it first to show you what it does. And it has, as you can see here, because of these black dots on the icon of the check, it has variables defined. And the variables allow me to specify how to find the cut line. So this is the spot color name for the cut line. And it allows me to say what the minimum distance is that I want. And I'm going to make that relatively small. I'm going to set it to 2 millimeters. So basically, I want to detect text that is closer to the cut line than 2 millimeter. Let me run that. And what you can see is that there is one match that Sifter finds. And if I double click that, it shows me that this best before is actually too close to the cut line, which is exactly what we would think if we look at this as well. This obviously is less than 2 millimeters from this cut line. Now, the check that we are performing is very, very exact. And to illustrate that, let me run this again. And this time I'm going to allow it to use 3 millimeters. So find text that comes closer than 3 millimeters to the cut line. So I run it again, and now I get 3 hits. And what do I get? Well, the first one is now for this letter Y. And why is that? Because it extends, well, a little bit too close to the cut line. I will have something similar here for the P, and then I still have the original text that we found. So what Sifter does in this case, and especially because you have this text that is on a shape, it's not a straight line, it will really do a check between all individual characters of this text line that you have here and the cut line that you are telling it to compare it with. So it's a very, very accurate way of running this check. How does it work? Well, let me open this preflight check that I have in here. And what you will see is that, again, I'm using one of these conditions. And the condition this time is object reaches into edge area of a shape. Now, the shape that is being used is shape defined by cut line. Yeah? And shape defined by cut line means that I'm using something that follows this cut line that I have in the document, and then I can specify the inner edge, which is the inside of the cut line, and the outer edge, which would be the outside of that shape, and I can define what that area is that I want to check. And as soon as a piece of text, and that's because of the first condition that says is text, as soon as a text object comes into that edge area as defined by these two distances, as soon as that happens, I get a preflight check. So again, it is not very complicated to set this up. You use one of the ContextAware object detection conditions, and in that condition, you define which objects you're going to use. The only complication here is that this particular condition does not work with two types of objects as we saw in the last one, but in this case, I define a type of objects that I'm interested in, and then I define a shape that I want to test against. Yeah? You'll see in other conditions that Sifter has those two possibilities, Sometimes it will compare one type of object, sometimes it's one type of object against another one, and sometimes it is a type of object against a shape. And this is one of these, this last category that we are using here. Now, this document also allows me to show something else that is interesting. And I have another check here that will check for invisible objects. And this time, let me look at why or how that works before we run it. And it is using a very simple condition. Object is invisible. Again, it is built on the Sifter technology, but the configuration is very simple. It says, give me a preflight error if an object is invisible, and then it allows you to specify which type of object. So if I would set this to its text, it would only find text that is invisible. If I set it to any object, it will find any page object that is invisible. Now, you could come back to me and say, hold on, you said that Sifter was about checking relationships between objects, but here you're only checking visibility or invisibility of one type of object. So what about the relationships? Well, of course, here the relationship is implied. If I want to know whether an object is visible or invisible, I need to check what the relationship is between that object and any other object on the page. Because any of these other objects or clipping paths could clip away my object, or it could obliterate my object. So there is a relationship that is being tested. It is simply implied, and you can only see the type of object that you are interested in this particular condition. So what does this do? Well, if I run this on this document, it tells me that there are 11 matches. So it found 11 objects that are invisible, and I can double click this to highlight it. Now the problem is, of course, that this is an invisible object and it's kind of hard to see invisible objects. Fortunately, I can use this show and snap button again, which shows me the object by itself without it being hidden by the rest of my design here. So I can go through this and see all of the different objects that are on this in this document that are hidden. So now that we know this, of course, you could start wondering, well, what can I do with this Sifter stuff? Is this just for pre-flight checks, or might I also be able to use this in Fixups? The answer is, of course, yes, you can use this in Fixups as well. And to show this, what I can do is I can use a fixup that removes invisible objects. How would I build one? Very, very simple way. You probably know, or you should know actually, because it's a very useful fixup, that pdfToolbox has a fixup called remove objects. And which objects are removed is determined by a pre-flight check. And that's the one that I have selected here. So again, if I would say, is text, then I would be removing all text from the document. Instead, what I'm saying is remove invisible objects, and that will remove invisible objects from the document. If I click the test button, it will run it and show me the result. It tells me that it removed 11 objects, but of course, this is kind of disappointing because the document looks the same. Well, it's actually not disappointing. It has to be the same because all we removed are invisible objects, so there cannot be a change. But we're still not satisfied by this. So what I'm going to do is I'm going to do something I would never do in production. I'm going to reverse the situation, and I'm going to run this fixup that says remove objects with, as a check, visible objects. So now I'm going to delete everything that is visible. And when I run that, it deletes everything that was visible. It leaves everything that was invisible. And as a result, you now see what was previously hidden. Yeah, just to show that, and no, this is not a production fix-up, but just to show that, or which objects would be identified with this is invisible check, and to show that it actually works also when running a fix-up. Now, let me run something that is much more production ready and that could actually be very useful. Let's assume that I get a document like this. In many cases, you'll get a design that has a label and the label has a cut path, but then there is all kinds of other information. We could refer to that as a legend or as junk, whatever you want. There's all kinds of other stuff outside the label. And if I want to show a preview of a proof of this label to a customer, I might want to have a document where I only have the objects that are belonging to the label itself. In other words, everything that is inside or overlapping with the cut path. How do I do that? Well, in pdfToolbox 9 with classic preflight technology, there's really no way of doing that correctly. In pdfToolbox 10, I can do something like this. Make a fixup, and I called it here, remove objects outside cutline. If I look at how that is created, it uses the same remove objects fixup we used before, and now it says objects outside of the cutline shape. And this, let me drill down, this uses a Sifter condition, objects outside other objects, checks against the shape defined by the cut line. So just as we did before, we create a shape from the vector elements using the cut line spot color, and we use that. And I want to know, or I want to hit on any object that is outside of that shape. Okay, so let me test that. And there is a variable in here, again, that lets me define what the name of the cut line is. In this document, it is actually called cut line, so I'm just going to go ahead. And when I run that on this document, as you can see, there are now 13 objects that have been removed. And in fact, all these objects that I had in the left upper corner that were outside of this label cut line have been removed. So to create a proof version, this could actually be quite interesting. Yeah. Okay, so I think this is more or less what I wanted to show you in this particular session. As I said, it's a little bit of an introduction to this technology. There are more examples if you look in the example libraries that come with pdfToolbox 10. If you go to the documentation website, there is a complete explanation of Sifter and all of the properties of Sifter. Also, all of the relationships that are tested with examples that you can use to very clearly understand what the difference is between covered and overlapping and crossing and obliterated, and all of these things are very nicely explained in there. So just go to help.callassoftware.com, look for the pdfToolbox manual, and there will be a complete chapter on Sifter with examples in there. Now, before we call it quits, let me remind you that you can type questions in this question box now, and now would be a really good time to do it. But I have one question that I already know of that I need to answer, and that is a question from Marcus. Did you do any speed tests on large files? Is Sifter much slower? Now, Sifter definitely is slower. There is no question about that. It has to be. It is much, much easier to look at each object on the page individually and test its properties than it is to look at object one and then start comparing it to all other 2,000 objects on that particular page. Yeah? So because of the fact that you're testing relationships between objects, necessarily this technology is going to be slower. We've done a bunch of testing on this, and on 2 different occasions at least. And when you do something that is relatively complex, for example, testing whether an object is inside or outside a complex shape in a document that contains a lot of different objects. Let's say you have a packaging file with an elaborate design. The packaging file has a a cut line and you want to remove everything that is outside the cut line, or check things against the cut lines, this check about text coming too close. In that situation, the tests that we did, the worst case scenario is that a Sifter check takes about 3 times as long as a regular check. Yeah, so that actually sounds pretty bad. But let me put it in perspective. So the worst case scenario is about 3 times. For not so complex checks, and with not so complex checks, I mean, for example, this black text set to knockout check, which does test relationships, but it's not with shapes, and it's typically it will only do the test for things that are black text that are small enough and set to knockout to begin with. So in that situation, you don't incur that much overhead. Testing pointed out that that was between 1.1 and 1.3 times as long as well, general classic pre-flight checks. So not too bad. The more realistic test is what would happen if you have a real world pre-flight profile, let's say Gantt workgroup profile, and you look at this profile and you identify all the checks where Sifter might make a difference and might help to get the number of false positives down. You implement all of those, and then you run that profile on a file and you compare it with the classic Gantt workgroup profile. In that scenario, the answer is that you end up in that second frame, if you want. So your modified Gantt workgroup profile will probably be between 1.1 and 1.3 times as slow as the or as quick as the classic profile, which is not a phenomenal increase to begin with. But secondly, when you think about the fact that with the Sifter technology, you can do things that previously you could not do. Well, there is no speed comparison there. You simply couldn't do these checks in the past. And secondly, the fact that you reduce false positives, then the speed decrease that you have because you're using Sifter is really completely irrelevant. What counts in automated workflows is not how long it takes to do a pre-flight check. I think what counts in those workflows is the quality of the pre-flight check. In other words, how good is it? How many problems does it identify? And secondly, how many false positives does it generate? Because each false positive that you have will let you lose a lot of time. You have to pull the document out. Someone has to look at it, or it has to go back to the customer to have him look at it. That's where you lose the real time and the real money. The fact that this pre-flight check takes 10%, even if it would be 3 times slower in any case, then I would still not be worried about it. So in real world use, I think there is no appreciable difference between a classic and a Sifter-based check. Yes, it will be slower, but no, it will not stop you from using Sifter in a real world scenario. The advantages will far outweigh the disadvantages. To summarize, we talked about Sifter or ContextAware technology, which is pre-flights, but not just testing individual objects, but testing relationship between objects. If you have any remaining questions about this, or you have questions on whether something is possible in your specific workflow, maybe stuff that you don't want to share in front of this audience, do not hesitate. You can see my email address on there, but you can also, of course, email to support@4ps.com or support@callassoftware.com. Both of those email addresses end up in the same question tracking database that we have. Ask any question that you have. This is really cool technology, but it sometimes takes a little bit of an effort to understand how exactly it would work in a given situation. And we will be more than happy to help you test what the best way is to accomplish something.